Welcome back to B-Spice. In this session, we'll continue with mastering instrument installation, wherein in part 3, we'll focus on instrument impulse lines. Okay, so let us go into the agenda. Of course, installation in control building and main cable we have already covered in part 1, and installation of field instruments we already covered in part 2. And now in this part 3, we'll focus on impulse line. And of course, we'll touch upon a bit on the analyzer sample piping. Not much, it's a brief one. And the few further heat tracing and other stuffs will continue in the subsequent sessions. Okay, so let's get started with this concept. Okay, first I want to inform you on this orientation of takeoff taps. Of course, you guys know, but I just want to, put forth again. Okay, so this is how I classify fluid. Liquids, general liquid, liquid vaporized at ambient temperature. Gases and vapor, general gases, vapors liquefied at ambient temperature, and steam. Okay, so these are the classification for fluid, and I also classified the DP as a flow, normal pressure, and DP level. Okay, case 1 and case 2. It depends on the applicability, so you don't have to worry about this. But yeah, this is a different scenario. Okay, so general liquids, case 1, horizontal, right? You can do like this, right? And angle downward, case 2, right? Angle downward. This is for the liquid. Then, if we talk about liquid vaporized at ambient temperature, of course, horizontal, case 1, and angle upward. Okay, so this is about the DP type. Okay, now we'll go into this pressure. See, pressure case, both are top. This one, okay, normal pressure, and of course, horizontal, case 2, right? Differential pressure level, we have a case 1, which is horizontal. This one, horizontal. Then gases and vapor, general gases, so and vapors liquefied at ambient temperature. So the case 1 is the top, okay? And you have an angle upward, right? This one. Then you have a horizontal, again angle downward. Okay, these are the scenario. And for pressure, of course, no change, top and horizontal. And for steam, case 1, DP flow, horizontal and angle upward. And for pressure, top and horizontal. So this is the typical orientation of takeoff taps. Okay, I hope this is clear, right? Okay. Now, design of impulse line. You know, we use for differential type, we use 5-way manifold, right? And for normal, we use a 3-way, right? So drain or vent plug shall be provided in all impulse line. That one also we should watch out for. Friends, in fact, I uploaded a video on hookup also. If you are a member, you can easily, view that. It's a hookup for all types actually. This is on top of this. For impulse line in toxic service, drain or vent valve shall be provided instead. Okay, instead of drain and vent plug. So Teflon thread tape or liquid thread sealant shall be used as a sealing pipe thread, sir. If the fluid contains solids or slurry, which may cause clogging, we need to take this precaution. What is that? Slope the impulse line upward to the instrument so that the solids can fall back to the process piping. See, if the fluid contains solid or slurry, which may cause clogging, slope the impulse line upward to the instrument so that the solids can fall back to the process piping. Okay. Enlarge the size of the takeoff and impulse line by 1 or 2 size. And of course, add pulse system. So this is about the design of impulse line. Okay. Aspects need to take care. Few more. T shall be provided in the top of each leg for the following services. What services? Flow measurement of steam service. We need to have this T. And of course, not applicable for superheated where condensate pots used. This is not example. This is except actually. Typo error. So flow measurement, the T shall be provided to the top of each leg for the following services. Of course, the flow measurement of steam service, but with the exception of the superheated. Because there we use condensate pot, right? Yes. So level measurement and of course, and differential pressure measurement for those services where a liquid static head needs to be compensated. Liquid static head where it needs to be compensated. What is this liquid static head? Basically, it refers to the pressure exerted by a column of liquid due to its height and density. That's it. Very simple. Okay. So seal pot shall be installed in the impulse line of instrument when the impulse line on the instrument need to be sealed with a sealing liquid. Condensate part shall be installed for superheated steam or vapor service. So this also we need to watch out during the design of impulse line. Okay, any question, please write to me, friends. Huh? Okay, in case of low range pressure measurement, that will be affected by liquid. Okay, static head in impulse line. The instrument shall be installed higher than the pressure tap. In case of a low range pressure measurement, that will be affected by liquid static head in impulse line. Again, the static head is nothing but the pressure exerted by a column of liquid due to its height and density, right? So that case, the instrument shall be installed higher than the pressure tap, and the impulse line shall be sloped upwards. These are the points we need to focus on, right? Then material. When it talk about material, of course, it goes with your project spec, but we can use this 3/4 OD or half-inch OD and 0.035 thick with SS tubing. Okay. Fittings, of course, compression type, SS fitting. So probably like you can have for a sway, you can use it swage lock or Parker, again based on your spec, and 3-way, 5-way manifolds supplied by the instrument manufacturer. Standard is used. Seal pot, condensate pot as per the piping service class, and vent plug should be SS, drain also should be SS, swage nipples as per again piping service class. Then threaded flange, again piping service class. Okay. So this is about the material specification. Then when we talk about the analyzer sample piping, we have to use this fast loop. Fast loop shall be provided. Okay. What is this fast loop? You may have a question, right? Yes. So basically, fast loop in analyzer sampling is designed to improve the efficiency and accuracy of sample analysis. How? By reducing the time it takes for a sample to reach the analyzer. That's it. Okay, good. So this is provided to for the analyzer sample piping to minimize the sample time lag. Operability and maintainability shall be taken into account when designing the layout, especially the location of sampling valves and utility valves around the analyzer. Okay. Specification of the piping shall comply with the applicable piping service class. Okay. So this is about the simple notes on this, friends, analyzer. Not much. Of course, I'm going to talk about a separate video on this quality measurement, wherein we talk about each type of analyzer in detail, including the design of, analyzer, shelter, tubing, everything in detail. Thanks again for watching. And if you want to support BSpice, you can show your support either by, simple by pressing the like button, or if possible, you can subscribe. And if possible, you can become a member. Okay. Thank you. Take care. Bye-bye.